10-5 Surface Area, Prisms and Cylinders. Our objective today is to find the surface area of prisms and cylinders. First of all, we have separate surfaces and using nets. So one way you can do it is to kind of break up the figures. So there's a little drawing of a rectangular prism, and basically think about it as a box, and you're taking, first of all, you got your top and your bottom. So what would be the dimension of the top and the bottom? So look at those, and looking at the numbers that go along with the lines or with the edges, what would be the top and the bottom? The dimensions. It would be 5 by 4. And since we have a top and a bottom, we're going to times that by 2, which will give us a total surface area for the top and the bottom of 40 units squared. Now let's look at the left and right hand side. So look at those two yellow boxes, and what would be the dimensions for the left and right hand side? Think about it a moment. What would you pick? What numbers? It's got to be either 3, 4, and 5, a combination of two of those. So hopefully you said 4 and 3, and again, since we have a left and a right side, there's two sides. That would give us 24 units squared. Finally, we have the front and the back. Of the three numbers, which two are we going to use for the front and the back? I did 5 and 3. Hopefully you chose those as well. And again, we have 2, the front and the back. That gives us 30 units squared. Add all those up, and you get a total of 94 units squared. So think of that as how much paint you would need to, if that was a house and you were painting the inside, the top, a whole room the same color. The walls, the ceiling, the floor, whatever. Now another way of doing it is to take it and to break, imagine it's a box and you're unfolding that box. You're unfolding it so you can stick it in the trash to recycle. Well, if you unfold it, could look something like this. Notice that there's basically 6 rectangles in there. So for a rectangular prism, we're going to have something like that. Now the tricky part comes in making sure you get all the numbers in the right spot. So we have the front, and we have all these numbers. So again, it gets a little bit complicated, but it's another way of doing it. So we have the two bases, the top and the bottom, and then we have this whole big long rectangle that we can combine together, and it has a perimeter of 18. Or sorry, not a perimeter, a base. And then we have our height, which is 3. So we could do 5 times 4. Then we have 2 of those. And then we have the perimeter, which is 18, with the height, which is 3. And we do our order of operations, we'll get 40 plus 54, which gives us 94 units squared. Again, the same as when we did it front and back. So you can do it whichever way is easiest for you. I tend to like doing the separate surfaces. I get a little confused on the nets, but whatever works best for you. Now, if you have a cylinder, cylinders are a little bit easier. If you think of a cylinder, you've got the top and the bottom. Think of a Coke can or Pepsi can or a can of soup, or, let me dig around here. My favorite example is a roll of towels. We'll come back to that in a moment. So you've got your bottom circle, or you've got your diameter, sorry, and then you have your height. You have the top and the bottom, so there's 2 circles for the top and the bottom. Remember to find the area of a circle is pi times r squared. But remember we have 2, so we're going to multiply all of that by 2. So in this case, We have 2 times 3.14 times 3 squared. Where'd 3 come from? Remember, that 6 represents the diameter, the distance all the way across the circle. We want the radius, which is from the center to the edge. So we basically divided 6 by 2. Then we'll do our order of operations and start solving it. And we'll get 56.52 units squared. Then we need the area basically around the paper towel. Call that the lateral area. Well, if we were to unroll this paper towel, roll of paper towels, notice that we get a rectangle. Well, the height of the rectangle is going to be 5, but remember I unrolled the paper towels, so that's the circumference, remember doing circumference, of a circle. And circumference is equal to pi times d. So in this case we got pi and our diameter is 6. Then we have our height times 5. So we're going to have pi times d times h. Which if we plug everything in, it's 3.14 times 6 times 5. Which comes out to 94.2 units squared. Add that up. And we'll get 150.72 units squared. Now if you want to do the net basically looks just like the separate surfaces. Doesn't matter where you put your circles. And you're basically getting the same thing. We have 2 bases plus the circumference times the height. Remember our bases are circles, so it's going to be 2 times pi times r squared. And we have pi times d times h. So we put in all that stuff. And you'll notice it's basically the same thing. So we'll get 56.52 again, plus 94.2 again. Add them up, and we still get the same answer. Next, we have a prism. And so, break it up. We have 2 triangular bases, plus, what else do we have? I see triangles. Do you see any other shapes in this figure? Think about it a moment. What do you see? Hopefully you see something other than triangles. And we've got some rectangles. How many rectangles do you see? Hopefully you're seeing 3. You have the bottom, you have the left, and you have the right. So we'll start with the triangles. And we have 1/2 base times height. And again, we have 2 triangles, so we'll multiply it by 2. So 2 times 1/2 times 4 times 3. That basically cancels out, and we end up with 12. Then we need to do our bottom. Well, our bottom is right there, and what are the dimensions of the bottom? Hopefully you're saying 8 times 4. That's 32. Now let's look at the left. Again, it's length times width. It's a rectangle. So on the left we have this. What would be the dimensions for the left hand rectangle? Hopefully you said 8 times 3, which is 24. Now we'll do the right. What would be the dimensions for the right hand triangle? 8 times 5, which is 40. So we add 12 plus 32 plus 24 plus 40. That gives us 108. It's a lot of simple math, but there's a lot of little parts. So you got to make sure, are you taking care of each surface area? Take your time. It's not complicated, but it is a lot of different things. So people can sometimes forget to do one part. It happens. Okay, would you try this one? See if you can find the surface area for this triangular prism. Pause the video, take a few minutes, look at the previous problem to try to give you an idea of where to go, and see what you can do. Come back when you're done. Okay, hopefully you paused and hopefully you tried it on your own. So we have two triangles, and remember we have the lateral areas, which are rectangles. We have a left, a back, and a front. You might use different names for them, but it's all the same thing. Again, to find the area of a triangle is 1/2 base times height, and we have two of them, so we're going to do 2 times 1/2 times 4 times 3, and we get 12 again. Length times width for rectangles, so we'll start with the left. It's that one. What would the length and the width be? Hopefully you said 3 and 6. That's 18. How about the back? It's going to look like this section. Hopefully you said 4 and 6. That's 24. Finally, we have the front. What would be the dimensions for the front? 6 and 5. That gives us 30. Add all of those up, and we get 84 units squared. And that does it. You're going to be doing page 443. Probably going to be doing all of it, not just the first 6. I believe there's 7, so I do need to correct that. Make sure you round to the nearest tenth and to the nearest whole number. And if you have any questions, post them on Edmodo or come in before school or during lunch, and I'll do my best to help you.